Joins, inner joins, outer joins, full outer join, right outer join, left outer join. Today we're going to be talking about joins, and I know you're really going to get something out of it, so let's go.
What's up everyone, we're back again with the intermediate series, but before we get started, I would advise for you to just create this table, warehouse employee demographics, so you can get up to speed with me. Alright, so today we're going to be talking about the joins. We're going to talk about the inner join, left outer join, right outer join, and full outer join. A join is basically a statement we use to join two tables together. Those two tables need to have an identifier, a unique identifier that can be matched on both tables so we can join them. Take for example, for the employee demographics, we have the employee ID, and also for the salary we have the employee ID, and they are both matching, so we can actually join them based on that. So without further ado, let's try to join them together. So let's say select everything from let me just copy this out so it can be very fast, and then we would say inner join. Let's copy the salary. Now we're going to join this based on a particular column. So the column is going to be the ID of both the salary and the demographics table. So it's going to be on employee demographics. Now you're coming out. Where is it, sir? Not demo. Employee demo. Oh my god. Employee demographics dot employee ID is equal employee, hopefully yes, employee salary dot employee ID. Alright, so if we should run this, execute, it should give us this output. Let me erase this a bit so you can see it properly well. Bring this down. Alright, so you can see our output. Basically we have two employee IDs. The first one is the one on the left, and then the one on the right. Basically the left side is the employee demographics table, which is the first table, and then the right side is the employee salary table. And as you can see, both IDs are matching from 1001 all the way down to 1010. So both are matching, which is as a result of this inner join. So if we check out this Venn diagram, we discover that we have two circles. The inner join is basically in the center. So what is this trying to tell us? It's saying that from these two circles, just return back everything that is similar on both sides, that both of them have in common. So on the left side, which is the demographics, the table, whatever that is common with the right side, which is this middle, should be returned back. So we can also do the full outer join. The full outer join is different from the inner join. The inner join brings back similar what it can match on both tables, but that of the full outer join return backs everything regardless of if there is a match on the other table or not. So if you notice, we have from 1001, or basically everything 1001 up to 1010. That's where the similarity ends, and then from the 11th row we get to see that this is a null value. So since this employee ID is null, automatically it means on the salary table everything is going to be returned as null, because it can't match anything that is null, so everything is just null. And then we have 1013. Despite the fact that this 1013 has name, first name, last name, and gender, it doesn't have a match on the salary table. And then if you look at the salary portion, which is the right side, we have a security who doesn't have any employee ID. So since there's no employee ID, definitely the data for the other side will be returned back as null. And 1012 has an employee ID, but it doesn't have any matchable data on the other side of the demographics table. So that's the full outer join, bringing everything into perspective. Let's talk about the left outer join. Now, the left outer join is talking about the left side of the table. The left side of the table is basically the demographics table. So everything that has to do with the demographics table. And if you notice, when we were doing the full outer join, the demographics table was having a 1013. Alright, so the 1013 is returned. Basically everything that, and the reason why we're saying Victor James here, which is a null value, is because actually the Victor James is in the left side, which is the demographics table. So, but they don't, both of them, both the row 11 and 12, they don't have a match on the other side of the table, which is the salary table. So everything, that's why everything is basically coming back as null. And if we check out this table or this picture again, we see that the full outer join, just like we did, is basically bringing everything into perspective, regardless of whether there's a match or not. And then the right outer join, which we just did now, is basically bringing everything from the right side, or from the left side rather, and then matching it up with anything that is matchable on the right side. But if everything that is on the right side that cannot be matched on the left side will not be returned, and it's basically the opposite when we do the right outer join. So let's try the right outer join. Right outer join, I'll discover that the 1013 we're seeing on the left side will no longer be there. So it's no longer there. But if you look at the left side, which is the right side basically, which is the salary table, we discover that we have a 1012 here. The 1012 is an ID of an employee from the salary table, but it doesn't have anything matching up on the demographics table. So probably it needs to be updated. When we start that particular one, we get to understand it better. Alright, so using joins, sometimes it's not really necessary to like put everything into perspective, because you're actually trying to get some information. So you may have maybe thousands of columns or many columns basically. Maybe you have like up to maybe 10, 20, and you're just trying to get some information from some columns. So you just need to specify. How do we do that? Well, we call on each of the columns that we may need. So let's say employee ID, let's do first name, let's do first name, let's do last name, let's do job title, and let's do salary. Alright, so if we try to run this, basically we're going to get an error, and because of this employee ID. So this employee ID is trying to like remind us that there are two employee IDs, that of the demographics and that of the salary. So which one are we actually trying to base it on? So let's base it on the employee demographics, and if we should put this, so employee demographics dot employee ID, if we run this, it should return this information. Okay, let's start from an inner join. Let's just match them up. So the employee demographics, now we can now see that we're just having an output of the employee ID, first name, last name, job title, and salary, just what we want to see. And then the employee ID, you get to notice that this particular employee ID is coming from the demographics side, Now, why are we seeing only from 1001 up to 1010? It's because it's an inner join. So basically trying to match the employee ID of the demographics and that of the salary. So it doesn't matter if we change these demographics actually to salary, it's still going to give us the same output. And the reason is because of the kind of join we're using, which is an inner join. So basically it's just looking for what matches on both sides. But let's change this to the right outer join. So the right outer join is talking about the salary table, and we're basing our employee ID from the right side. So we get to see that 1012 would appear. So 1012 is actually from the salary table, and it was actually the supply relation. It doesn't have a first name or a last name. I think even age and gender, it doesn't have on the other side of the table, which is the demographics table. If we should change this salary to demo, you will discover that the output would be different. 1012 will no longer exist. 1012 no longer exists. Even though the supply relation is still showing 1012, we know that 1012 is actually the supply relation, but 1012 is not having, it's not appearing as the ID, and it's because of these demographics, employee demographics that we are hitting off of. This is the employee ID of the demographics, and in the demographics there's nothing like 1012, just 1013. And if we want the 1013 to actually appear, we just need to change the right out join to the left. And if we run this, we'll have the output for the left side. So we have 1013. All right. So let's say we have a use case where, let's create a scenario, a use case scenario. Basically, let's say the manager, which is Elizabeth Sunday, the company she's managing is actually getting to the end of the first quarter, and she's trying to meet up with her quarterly quota, the amount she's supposed to make. Let's say 2,000 naira was actually remaining, and she comes up with a plan to actually deduct money from a particular employee who's probably making a higher amount, the highest amount besides her. So she makes the highest amount with 75,000, but she wants to deduct some amount from the next highest paid person. So she comes to SQL, and basically she would want some information. Of course, the employee ID will be one of them. She want the first name, of course. First name will be important. She also want to know the last name, then the job title, and also the salary. All right, so we need to base this off of a particular table. Let's use the demographics table and dot employee ID. All right, so let's run this, and then immediately we can see all the employees and their salaries. So let's say she wanted to narrow it down to those who don't have no value. So let's do an inner join. So an inner join gives us this output. All right, so now she knows she's the only one who is Elizabeth. So she wants to single herself out of the whole thing. So she'll say where first name is not equal to Elizabeth. And when we run this, Elizabeth is no longer in the picture. All right, so let's try to order this. So let's say order by salary. because we want to know who is the highest salary earner. And let's do this in descending order. So let's run this. And then we see that Thank God White is actually our man, the assistant manager, earning 65,000. So 2,000 naira will actually be deducted in order for the manager Elizabeth Sunday to meet up with her quarterly quota. Alright, so let's do another use case. So let's bring everything to perspective. Let's say full outer join. And let me just copy this and keep it somewhere. Let's copy Ctrl X and let's see everything. Let's say full outer join. So let's see everything. Alright, so the HR Yahya Abdul, let's say the company absorbed some new employees, but some of their details have not been added yet. Details like their salaries, and they want to compile actually the salaries of all the employees for the end of the month, because the month is coming to an end. So before they start updating other ones, they actually just want to know how much they are going to pay. So they want to update the salary. So Yahya, who is the hiring manager, comes to SQL and tries to find out how many of these staffs have their salaries not been updated yet. So he comes to SQL, and then of course you want to know their employee ID, their first name, last name, job title, and salary. So if he runs this as a full outer join, he gets this output. So all he just needs to do is to say where salary is null. Salary is null. Then when he runs this, so Victor James and Philip Job, basically their salaries and job titles have not been updated yet. So he knows that there are two employees whose salaries have not been updated. So that's basically some use cases. If you really enjoy this content, please do well to smash the subscribe button, like this video, share to your friends, and I'll see you